There are three different types of people in this world. There are those who can count and those who can't. Wait, that doesn't make sense. There are this many different types of people in the world. There are those who understand binary and there are those who don't. Or maybe there really are only just two different types of people in the world. Those who can extrapolate from incomplete sets of data and, well, you know. Actually, in this world, there are really just those who don't understand how cool math is and those who do. And that's why I'm giving this speech. Today, I'd like to take you plus you plus you on a 600-second long journey through the world of math. Because of this time constraint, however, I'll be subtracting all the unnecessary components from my speech and, for organization's sake, dividing it into three different points. First, we'll look at the concept of mathematics. Next, we'll look at mathematical advancements via discovery throughout history. And finally, we'll conclude by learning that math is more than just a way to, quote-unquote, manipulate the world. Before any quality discussion of mathematics can occur, however, we all must understand the concept behind mathematics. When one begins to study math, it becomes easy to get caught up in the whirlwind of information permeated by numerals. We memorize numbers, we memorize operations, and we memorize formulas. But simply put, this constant barrage of information desensitizes us to what the true meaning of mathematics is. Let's start with the basics. Some of the first things that we learn regarding math as children are simple numbers. We learn to count and we learn how to express numbers through notation. What must be kept in mind, however, is that these numerals that we use just represent ideas. The truth of quantity exists inherently in creation, and countless people have come to numerous different conclusions on different ways to write down and express that idea of quantity. For example, we use a numeral that we call 3 to indicate an idea of 3-ness. However, indicating this idea by writing 4 minus 1, 9 divided by 3, 3 tally marks, or even this little squiggle is not wrong. Doing so is merely another way of expressing an idea. When we look at operations, the same truth is found. Addition, subtraction, multiplication, division, exponents, logarithms, antilogarithms, summation notation, linear notation, all of these are operations that can be written a certain way, and while the way in which they're written can change, the truth that they represent cannot. Quantity can always be added to, subtracted from, multiplied by, etc. So, for example, it didn't take a human to invent something like multiplication. It only took a human to standardize the way that we communicate that idea of multiplication. And yet again, when we look at formulas, the same truth is found. For example, the force of an object is equal to its mass times its acceleration, because the idea that we call multiplication represents the relationship between an object's mass and acceleration in terms of force. Equations like this are always representative of truth, even if they seem arbitrary. PV equals nRT, a squared plus b squared equals c squared, e equals mc squared, and d equals m over v are all equations that look as if some smart guys in lab coats threw some letters, numbers, and operations together in order to invent things like atomic bombs, microwaves, and synthetic rubber. But the truth of the matter is that some genius first discovered a standard way to communicate that idea of quantity. After that, more individuals came along and realized that that notation of mathematics could actually be manipulated by using operations. And in the final stage, even more intellectuals realized that those mathematical manipulations represented inherently true concepts of the world around them in a form of formulas. Now, if you look all the way back throughout mathematical history, this is the way that math development has been progressing since the beginning of mathematical history. And that means before the Roman Empire, and yes, even black and white television. The Sumerians are credited with being the first civilization to use numerals as a form to, or as a way to express quantity. However, the Babylonians should be credited with fully developing the system. The Babylonians used a unique numeral for every number through 60, where they then began moving the figures to the left in their numerals. This was a system of place value notation, and interestingly enough, the Babylonians are credited with being the first civilization to use it. Now, at that time, mathematics was primarily used to keep track of a finite number of things. Specifically, society was very focused on agriculture, and so members of the society wanted to keep track of time. For example, if they could divide a year into months and months into days, then they could better keep track of when to plant and harvest their crops. It wasn't long, however, before the Babylonians wanted to build an empire able to withstand anything. And in order to do this, new advancements in geometry and trigonometry had to be made. Fortunately, the Babylonians were up for the task. This was demonstrated when a tablet was found about a century ago that dated back to the time and place of the ancient Babylonian Empire. Now, experts on this tablet thought it contained some sort of ancient mathematical notation, and these experts were proven correct when the tablet was decoded in August of 2017. The real shocker, however, lies in the fact that the trigonometric tables, for that is what the tablet turned out to be, happen to be more accurate and precise than trigonometric tables that we've been able to produce today. Moving beyond the Babylonians in history, we reach ancient Greece, who produced many more mathematicians who contributed to mathematical advancements. Pythagoras proved the well-known Pythagorean's theorem. Euclid developed postulates still used in geometry today, and from Archimedes blossomed the idea of exponents as well as the discovery of the value of pi. Moving further ahead in history again, we reach individuals such as Isaac Newton, instrumental in the creation of physics, and Euler, whose studies of mathematical notation brought about probably the most profound equation of all time. This equation related every single major mathematical constant to each other one. And who could forget Albert Einstein, who found the mathematical relationship between energy and mass, two attributes originally thought to be completely and utterly incomparable. Now, obviously, there are a lot more mathematicians who I haven't mentioned in this speech and who definitely deserve to be commended. However, I simply don't have the time to do that here. Those whom I have mentioned are sufficient to make my point. These mathematicians do not create these equations and formulas and ideas out of nothing and then use them on the world around them. Instead, what they do is they look at the truth in the world around them and learn how to express that truth mathematically. Or to put it another way, these mathematicians do not equal mathematicians who conjure equations out of nothing and use those equations to manipulate the world. Instead, mathematicians are avid observers of reality who recognize that inherently true concepts can be expressed mathematically. When one begins to realize that mathematics and numerical laws and principles govern everything about the world around them, an appreciation for mathematics can begin to form. It doesn't take long for one to realize that mathematics is an invisible hand that dominates all of reality. As Stratford Caldecott argues in his book titled Beauty for Truth's Sake, quote, even a materialist must regard numbers as part of reality while puzzling over the fact that they are made neither of matter nor energy. He can't observe them through any scientific instrument, yet somehow they underpin everything we see around us and help to define its form, end quote. Clearly, mathematics explains the unity of the world around us. But this actually leads us to a problem that is found in our society today, and that problem can be traced back to our public system of education. Stratford Caldecott makes another observation in his book when he says later, quote, our system of education has eliminated the symbolic dimension of mathematics altogether, reducing everything to sheer quantity. Mathematics is regarded as a form of logical notation, a mental tool with no relation to truth except the fact that it assists us in manipulating the world. This elimination of the symbolic dimension of mathematics is largely responsible for the divorce of science from religion and of art from science, end quote. Clearly, we see a problem in our public system of education. What it has done is taken one of the most profound and foundational truths of all time and separated it from the curriculum that they teach. The effects of this are widespread and detrimental to say the least. It's no large leap in logic to claim that those who don't understand how foundational math truly is don't understand that we live in a universe and not a multiverse. We live in cosmos, not chaos. Order and unity pervade all, yet people claim that reality is subject to the wants and whims of individuals. So, to conclude, math is pretty awesome. A lot of people don't understand that mathematics is just a way to notate inherently true concepts in the world around us, but now we do. Furthermore, it was demonstrated that every mathematical advancement in history came about because of observation of reality and not from creating equations out of nothing. And finally, we saw a problem in our society, where our public system of education has actually separated truth from math in their curriculum. At the end of this speech, there's really one thing I want you to take away, and that is that there are two different types of people in the world. There are truth seekers and there are world manipulators. For your sake, as well as for the sake of future generations, be that truth seeker.